Welcome everyone. Today I'm going to talk about how to develop with the blockchain. My name is Oz and I've been working on this project for the past few months. So what I want to first get started with is an introduction about the Ethereum blockchain, what it is. So the Ethereum blockchain is a decentralized ledger and it's stored on a distributed virtual machine, and you can interact with it using something called smart contracts. The cool thing about the Ethereum blockchain specific is it could be public or private. And Ethereum runs on Ether as a currency. So as Bitcoin has Bitcoin, Ethereum uses Ether, and gas is used to fuel different transactions. Gas is essentially like a small version of Ether. What does Microsoft provide? Microsoft provides a lot in the blockchain realm. First off, on Azure, we offer blockchain as a service, and what that is a Strato VM instance hosted by a company called Block Apps. For Visual Studio, we offer a Solidity extension. Solidity is the JavaScript-like language they use to write smart contracts. We're working on something called Project Bletchley, which will be like a big open development platform for blockchain, and many more. What is the goal of this webcast? So like I said before, this webcast will be for developing for the blockchain. It won't go into specifics about how the blockchain works. It'll be more of how to use the blockchain for development. I'm going to talk about Solidity in the language, the right way to write a smart contract. I'll talk about how to interact with the blockchain using Block Apps. Block Apps is the API that Microsoft provides through the Strato VM on Azure. I'm going to talk about how to build a front end for your blockchain, and I'm going to show off a demo app that I made. The demo app will be using Xamarin Android. I'll also have an angularjs web app. Additionally, I'm going to talk a bit about where the future of blockchain could be and some helpful resources for the future. Again, I want to emphasize that this is not a complete tutorial, and it'll be starting from a spot where I assume you already have some knowledge on what the blockchain is. A bit more, like I said, it's an introduction to smart contracts and using Block Apps. I'm specifically talking about Block Apps and using that system. I also want to emphasize that it's not a completely decentralized environment. In my case, I'm using Azure to store some information. I have my VM running on Azure, and so forth. This is more aimed for like a business application or a demo to show off the blockchain. So let's get started with smart contracts and Solidity. Like I said before, smart contracts are built on Solidity, and Solidity is a JavaScript-like language that's used to write smart contracts. The smart contract itself is just a piece of code on the blockchain. It's public, accessible to anyone, and what that means is you have to keep it secure. A smart contract is like a state machine. It exists on the blockchain, and it dictates what could happen at certain times. Since the smart contract is public, you have to be very careful about what it can and cannot do. So you need to make sure every state is secured and all conditionals should be considered. Solidity offers something called function modifiers, which are like extractable if statements. So you can make sure that certain functions of your contract are only accessible by certain people or in certain conditions. And they help a lot with adding an extra layer to security. Another important thing to note in smart contracts is to make sure the balance of Ether stored in a contract is only available to those intended. You don't want someone to be able to look at this smart contract and extract all the money and take it to themselves. You want to make sure you don't post anything public or anything private on the blockchain. You want to remove sensitive information. You don't want private keys there, passwords, any other sort of information you don't want out for the world to see. Now that I've talked a little bit about what contracts are, I want to show you a short sample contract. What this is a sample contract about storing something, a variable, on the blockchain. I'm going to show you how it changes the state. I'm going to talk about function modifiers and how they would be implemented, and how to ensure everything is working correctly. The website you see here is an online compiler for Solidity, and it's very helpful. I'll provide the link below later. So as you see, I have this contract called storage, and I have an owner of the contract. I declare the owner in the constructor. So what happens is when the contract is uploaded, it's going to look at who's the sender of this contract uploader and set it as the owner. Later on, I could go ahead and use this owner under a function modifier to make sure the only person that could access a function with this modifier is the owner. As you see, what I do is I could have the owner store something. So the owner would go ahead and call set item on the blockchain and pass in some sort of string, and then that item will now be what he passed in. Additionally, I have like a boolean to switch the states so it's easier to see what's going on. How about sending ether? An important part of the blockchain, of course, is sending currency back and forth between people. Solidity has a built-in send method where you would have the address of the intended recipient, .send, and the amount. And it's important to note that this function returns a boolean. So what you always need to do is consider that the send function worked. Here's a short example of how it would work. Again, you're sending an amount in way, not ether. So you need to consider the conversion between ether and way. Conversion is about 1 to 1 trillion or so. Like I said before, you want to check the return type before changing the state. So here's a proper example of how I'd use the send function. What I'm doing is I'm sending the balance of the contract to the person that requests it, and I'm then changing the state only if the send function went through. In this case, I'm not doing the correct way. I am sending the balance to someone and automatically changing the state to true. I don't know if this send went through or not. The reason send could fail is if the recipient runs out of gas or the call stack depth is at a certain height. Now, how do we actually interact with the blockchain? We talked about how to write to the blockchain, but how do you have something move? How does something get started? So the blockchain is a backend. It's a way of storing something, and smart contracts are a way of running something on that backend. But you still need a front end to interact with it, to have buttons, an interface for easier to use. So like I said before, I'm using block apps, which provides a very easy to use API that interacts with their block node server that's running. And then I have a front end. I'm just going to be communicating back and forth between the two. So I'm using block and block apps in that environment that Microsoft provides. There's many ways to develop for the blockchain. A few of the other popular ones are using Mix DApp, which is an IDE that you can develop with and see what's going on with your smart contract and step through the states. There's Truffle, there's many others. You should choose based on what you're familiar with and what your end goal is. If it's a proof of concept, or how much time you have, whether you want it completely decentralized or not, whether you want to control the environment and so forth. Block and block apps is very easy to use, and after following this tutorial, you could get very far with starting blockchain development. So let's talk about setting up block. If you go to their link on the GitHub, you can see how to do it. Essentially, you want to install the block module. You'll run block init, and when you do so, it'll ask you all sorts of information. You'll name your app, and then you want to enter that folder. So here I named my app demo, and I'm entering the folder demo. Run npm install, and then run block start. What block start does, it starts the web server, has it listening on localhost, by default, port 8000. Now that you have the server running, you want to start doing something. I'm going to show you how to create a user, and I'm also going to later show you how to upload a contract and access that contract. So to create a user, I'm using something called Postman, which is an easy tool for sending requests. And then once I implement Postman methods correctly, I go ahead and put them in my front end. So as you see, I'm sending a post request to an address. It's running on localhost 8000. And as their API documentation says, I want /users. And if I want to create a new user called admin, I'd put in the name. The two arguments for creating a new user using block apps are password and faucet. So here I set the password to be password, just generic. And faucet is a way of loading an account with Ether to test. So I want to keep the faucet on. I want to turn it high. You see when I send the post request, I'll go ahead and get back the address of where that user is located. So right now on my block app server, I have a user called admin. His password is password, and his address is this address listed below. If you check your terminal, you'll go ahead and see that it should be successful. So we have a user. What about contracts? Contracts are very similar. You're going to have localhost users, and then you want to have the user you're posting from. So in this case, the contract I'm uploading will be posted from the user named admin, and then you'll have his address, like we said before, and /contract. The arguments for uploading a contract are the password of the user that you are sending it from and the source of the contract code. So in this case, password of admin is password, and the source is going to be the copied string of the contract I showed before. So last time I showed that contract called storage, and I'm going to go ahead and just copy it into here. And when I send the request, as I did with the user, it'll return to me an address. Now that address holds this contract. On the blockchain, I now have a user named admin at a certain address, and I have a contract called storage at this certain address. It's important to note that this contract has no comments. What I did was remove the comments from before and copy and pasted the entire contract as a string. The blockchain has trouble interpreting the new line break and so you have to keep it all in one line. If you remember that contract from before, it had a method called setItem. This screen is going to show you how to call a function in a contract. I want you to note that I now have a header to my request as a JSON, and the request is going to be sent in this JSON format. So this time there's 4 arguments. I have the password argument, and again I'm sending it from the admin, so the password is password. I have an argument called method, and I want that method name to match my name in the contract, which was setItem. Now I want to list the arguments of that method. SetItem took in an argument x, and that's what it's set to its state later on. So my state x will be something called demo item, and value is the value associated with the message you're sending to the contract. So in this case, it's 0. What value means is the amount of ether you want to send over. So in the case of wanting to load a contract with 10 ether, you would have 10 passed in under this value, and it would subtract that 10 from the user sending out this function call. The post request, like before, is localhost 8000 / the user. Now you want the user and his address, followed by the word contract, followed by the contract name and the contract's address / call. This is all in the block apps documentation. I just wanted to show you a quick example of how it would work if you were to use Postman or you just wanted to have a full tutorial. So now that we did some requests and we're interacting with the blockchain, how could we see that it's working or what it's doing? Block apps provides a very cool interface to see what's going on. You could view things such as account balances, contract balances, their state, and so forth. If you wanted to view the information of an account, you would go to their Strato endpoint. So in this case, their most recent endpoint is stratodev4.blockapps.net and their current version of Ethereum. And you want to filter by account and address. So if you remember, the admin's address looked like this. You'd paste that into the URL and you'd get in return a JSON that tells you the user's contract root, his balance, address, where he is on the blockchain, and so forth. As you see, it does show a lot of information. Sometimes you might only be looking for balance, or you might only be looking for the address. What about contracts? Contracts are also very easy to see using Block. You would go to your localhost / contracts, and it'll give you a list of all the contracts you've uploaded. So in this case, I have that contract storage. I've uploaded it twice before this demo, so you can see there are 2 addresses here. And if I were to press on it, it would load its state. It would show me more information about the contract. So in the case of pressing on it, I would see for the contract storage, I had a state, I had an owner, and I had an item, and I had a boolean called item stored. You'd be able to see its initial condition, and after I call that setItem function through Postman, you can see that I now have item stored. The owner stays the same. The item is now demo item, which I passed in as X, and I switched to item stored to be true. Again, this is me stepping through every state of the contract and just an example of how you would start debugging. So it's a bit difficult to debug on the blockchain because there's so many numbers and addresses and different places to look. So it's important to stay organized. As you saw here, I have a lot of tabs and I have to jump back and forth between screens to see that everything works. So it's important to label everything very clearly, make sure your states are well defined, make sure you use a boolean to see what's going on, make sure you change states only when appropriate, and make sure you test multiple times before making your code public. what you could also do, which I did and I'll show you later, is build a parser for all this information. So currently, from one URL, I get a response, from another endpoint, I get another response, and I want to match them. So I built a quick web app that will take data from multiple points and put them in one location. I put them in a table and I'll make it easy to read. So how does this actually work? Where can I actually see the results? And that's through building a front end. First of all, why would you need a front end? I mentioned earlier that a front end is useful because you need to have a user-facing program to begin a transaction. No one really knows where to go if you just have a smart contract hosted on the blockchain. You need to interact with it somehow. And the logic of your program should be in the smart contract. The front end is just a button press to interact with it, or an easy way to use what you intended. I want to talk about my example, what my app is, and what I'll be showing you in about a few minutes. So what I have is an example app of a child wanting to buy something. In this case, it's a child wanting to purchase something from, let's say, an app store. And when the child goes ahead and purchases something from the vendor, it will ask the child's parent, hey, is this child approved to buy this application? And the parent could go ahead and approve or deny that request. And if that parent approves the request, they'll go ahead and send money to the vendor. If he denies it, it wouldn't send money to the vendor. And all the interactions behind the scene are handled on the blockchain. So a user could come in and see that a parent approved X request to a child at this time, and this was exactly what happened. Here's a quick chart of what exactly I mean by this. I have these relationships set up between parents and children outside of my application. So this is where my application is not completely decentralized. I'm depending on tables and Azure to determine my registration system. In the real world, this could be something like Microsoft having their email accounts linked between a child and a parent, and that's where these dependencies would be declared. And I have a vendor outside of the blockchain. So when a child or a parent wants to purchase an app, it will go ahead and go to the blockchain, look at the smart contract hosted on the blockchain, and determine, okay, the vendor requires 12 Ether, and that Ether will go ahead and be transferred to the vendor. And then later on in the future, anyone could go and check out the situation and verify the truthfulness of this. That's the beauty of blockchain, and where it really comes in handy is that it's trusted and dependable. So even down the line, no one can dispute the fact that child 2 requested parent 2 for an app, and parent 2 approved of it, and the money went to a vendor. So for my front end, what I did is I built a sample Android app using Xamarin, and then I have a web app to display a lot of the information in Angular using Azure to store some information. I have a block app Strato VM running, which is what we also offer on Azure, and that runs off the Ethereum blockchain. Now it's time to show the demo. On the left side here, I have my web app, and it's going to parse all the information I have and match it up in a nice little table so I can see what's going on with each request and how. And then on the right, I have a video of my app. What I'm going to do is be sending a request from a child. I'm going to show you how a child would send a request through this sample app, and then I'm going to log in as a parent, view that request, and approve it. Once I approve it, you'll see the contract balance go up because the parent has approved the request and it's sending the money to the vendor. And to save time, I'll have the parent immediately request for a refund, so you can see the money be directed back to the parent instead of needing to wait the refund period for the money to go to the admin or the vendor. I'm going to go ahead and start these. So as you see, I'm logging in as a child on the Android app. This is using my own registration system that could be substituted later on for whatever native registration on each OS is. I can view child's information, but what I want to do is send a new request. So I go ahead and press the new request. I'll get a notification that I sent a request. If you go ahead and check out my web app on the left side, you can see if I refresh the page, there will be a new contract uploaded. If I press on that contract, I can see the request the child just sent. I can see information such as the child. I can see the parent is involved. I can see their address. I can see their balance. I can see the contract's address, the contract's balance. If I switch to the state tab, I can see the state of my contract. I can see that I only just sent the details. It's not approved yet. I can see that I have 60 seconds to refund and so forth. I'm going to log in as a parent on the right hand side and check out my panel. Here I'm going to view my request, and here is my request that I just sent from the child a few seconds ago. I'm going to go ahead and approve it. If I refresh my web app, you'll notice that the contract balance will go up by the item price that I defined on the bottom. You can see that my state changed also. Now if I check the parents' balance, you'll see that it will drop by 12 trillion and the contract balance will go up by that number. Now what I want is to ask for a refund. So if you saw on the right hand side, I unchecked the check mark, and what it's going to do is change the state of the contract and give a refund to the parent. As you see, the contract balance is now 0. My state is a refund occurred. Transaction's finished. It was refunded. It was approved at one point. This is how much the item costs, and so forth. Now let's have a look at the code of the contract I was using for that sample app. If you remember, that sample app had a lot of conditions. I had a requester, I had an approver, which were the child and the parents. I had a vendor, which was in this case an admin that I was sending money to. So what I have is a few function modifiers to make sure everything is working correctly. I can make sure only the requester could access something, only the approver could access something. To handle refunds, I have only if refund period ends, and what I do is I check the current time, which is a keyword now in Solidity, and check that it's greater than the start time and the refund period I defined, and so forth. You could have a look at this contract code on GitHub. I'll post it at the bottom. I want to just keep going. Here is some of the contract logic. What I have is I have the constructor. When the contract is uploaded, it will hard code the vendor. So in the real world, the vendor would provide a contract to someone when they purchase the app, and that smart contract has their address coded in, so they could have money sent to them directly instead of someone purchasing an app and being able to send it to someone else. A child could set the details, who its parent is, how much the item costs. In this case, again, I hard code just a generic 12 as the item cost, as you've seen before, but this is something that the vendor of the app would provide in the contract. I could store a decision based on the parent if it's approved or denied. I could request a refund, and now I want to talk a bit about sending the balance to the vendor. In my demo, you saw the money go from the parent to the contract, and then it went from the contract back to the parent because the parent asked for a refund. At no point did the money of the transaction actually reach the vendor, and that's because you need to be able to call the function of sending money externally. So in this case, after the refund period is over, someone, it could be the vendor, needs to go into the contract and call this function, and what it will do will send the vendor that money. Ideally, this entire process will be done by something called an oracle. What an oracle is sort of like a smart user hosted on a contract that isn't controlled by anyone. So that oracle will be similar to like a web job, and it will know at this time and at this condition, do so and so. So ideally, the whole contract flow would work as in a parent would approve the request, the contract now increments by that balance, and when time runs out, an oracle would decide now that time is over, the vendor deserves their money, and will go ahead and forward the money to the vendor. How about how I worked in the Xamarin app? So Xamarin runs off C#, and this is just a short code example of how to use HTTP client in C#. You declare the client, you'll pass in the URL you want to access, the URL you're posting to, the argument, the headers, and so forth. You could have a look at this on GitHub. And now I want to show you a short code sample of how I parse the responses on my web app. So in this case, I'm building a table to view the state variables. This was the second table I showed, and then I bind it to a state table array so it's visible in the view. What I'm doing is I'm hard coding a few keywords that I'm looking for. So in my contract, I'm only looking for like the state, if it's approved, if it's an escrow, if it's finished, and I go ahead and iterate through the array and make sure that the JSON response that block gave me matches these keywords, and I go ahead and add those keywords to a table, and then later on I view that table. Looking ahead, what is the blockchain going to be used for in the future? What is the end goal? So first of all, blockchain is a very hot technology currently. It's summer of 2016, and a lot of companies are starting to explore. Microsoft is investing heavily in blockchain, and they're building something called Project Bletchley. You could also look forward to better Block Apps API, better development tools, more extensive smart contract tutorials. A lot of the Solidity documentation is sparse and is missing important pieces. Look forward to having Solidity, the language, natively recognized in IDEs and text editors instead of needing extensions and to build tools for it. And a big thing I'm excited for is IoT and the blockchain. What could it be used for? So IoT could automate a process, and the blockchain can verify an automated process. So together it can be very powerful. An example is something like Microsoft will use a drone to ship a Surface to a customer. That drone is a registered user on the blockchain, and it has a smart contract associated with it. So once the drone delivers the Surface, a smart contract can be executed, and that smart contract has a method that sends a payment to Microsoft. So it'll automate a payment upon arrival, and the drone is the only person that can access that contract, and the drone will now be reliable and responsible for sending the money. And when it's delivered, the drone will call that contract, and the funds will be released to Microsoft. Where else can you read more about the blockchain? So I provided some links to helpful tools I've used. Like I mentioned, this tutorial handles Block, and you can find that on their GitHub. There's a really cool Visual Studio extension for Solidity you could find here. A very, very useful tool that I've used is the online Solidity compiler. You copy and paste your contract code into it. It'll tell you if you have any errors, what you need to fix, if you're missing anything. I relied heavily on Postman to test. So Postman was the screen I showed earlier where you could send requests with a click of the button. So here's a link to get Postman. And in order to make a lot of the experience easier to read and easier to navigate, I have a JSON preprint Chrome extension. So when Block gives me a JSON in return to a request, I can see it formatted nicely on my computer. Some documentation tools that might help. The Solidity documents are being updated very often. They help a lot. They have some sample contracts there. They teach you how to do basic things like sending ether back and forth, how function modifiers work, things you could do with contracts, the future of blockchain, and so forth. There's a link to Block Apps API and everything Block could do. I'll leave a link below of some of my work. I'll show you some sample contracts, the two I have in this PowerPoint, the storage one and the request code. I'll have the code for my Xamarin app in a way that you could go ahead and run it yourself, and same with the web app to parse all my responses. Finally, there's some other tools I wanted to touch on. You could read more about Project Bletchley here. You could see what Microsoft offers blockchain as a service on Azure. And if you're interested in keeping up with the news, I found coindesk.com to be very helpful in seeing what you could do with blockchain. So that is the end of my presentation. Thank you for listening, and I hope you're excited for the future of blockchain.